Welcome everyone. In this video lecture, we will solve a numerical based on operational amplifier and it is from the Microelectronics circuits book. So the question is the circuit shown in figure A, this one is a figure A circuit, can be used as a transresistance amplifier. Okay, so transresistance amplifier, the equivalent circuit I have already drawn means having Ri input impedance, we are giving some current input as a current input and this control voltage like Rm II, okay, and R naught is the output resistance, I naught V naught. This one is the equivalent circuit for a trans resistance amplifier. Okay, so find the value of input resistance Ri, the trans resistance Rm, and the output resistance R naught of that particular trans resistance amplifier. This op-amp is used as a trans resistance amplifier, and if the signal source is shown in figure B, we are giving a input current source like this as shown in figure B. So we have to find the output voltage V naught, we can say output voltage V naught. So okay, so this one is this amplifier, operational amplifier can be used as trans resistance amplifier. So here we can easily say the open circuit, the Rm value, the open circuit trans resistance is nothing but simply Rm. So this Rm is nothing but simply V naught by I of I. Okay, by keeping this I naught 0, and this unit will be simply volt per ampere or ohm. Okay, so this one is the Rm value, so it is important. Rm V naught by II we have to find, and this one is the open base circuit is shown in there, so we have to find Ri, Rm, R naught, everything. Okay, and ideally for the trans resistance amplifier, the Ri value, the input impedance will be 0 and output impedance will be 0. Okay, so this one is the important observation, Ri 0, R naught 0. Okay, so now we will solve this problem. So this one is the circuit, figure A. So what we are doing, and we are giving this as a input. So what we are making the, we are just redoing the same circuit by including the current source. Okay, so this one is some current source. Okay, so what we can do at the input. Okay, so this one is a 10 kilo ohm and 0.5 milliampere. So for the time being I am saying this as a II. Okay, this one is the input we are adding here. Okay, and this the transistor, no sorry, this amplifier is a operational amplifier. So and it is the ideal one, means A value infinity, the A value is infinity, so we have to use the virtual ground concept. So the voltage across this point will be simply 0 volt, or if you are saying this one is a Vi, so Vi is nothing but simply 0 volt due to virtual ground. Virtual ground. Okay, due to virtual ground, this voltage will be simply 0 volt. So the we have to find Rm value. So Rm value will be V naught by II. Okay, and this one is V naught. So this II will go like this, II. Now this voltage is 0 volt and this one is 0 volt. So the current in this will be also 0 ampere. So this II will be go like this and it will go like this. And in this one also the current will be 0. So this same II, the current source give a 0.5 milliampere, go like this II, and this. So II will flow like this. Okay, clear? It doesn't mean this is open. You have to make it like this. Plus of minus V naught. Okay. Clear? Means it is going like this. The II current will flow. Clear? Means II go. It will not go in this direction and in this direction. So the equivalent circuit, once again I am making the same circuit. Okay. So there is no use of this RI resistance. So what we can do means this one is our simply II, that is our 0.5 milliampere. Okay, and this voltage will be VI, or this VI, I am saying this voltage, the inverting in 0 due to ground potential. Okay, so now we have to find the value of Rm. Okay, or first in the question what they are asking, first find first find Ri, input resistance. So as we know, input resistance for the transistor by 0, so but Ri, the resistance looking from this side, okay, is our Ri. Okay, so this Ri can be written as what, Vi by Ii. Okay, so due to virtual ground concept, this voltage will be 0. So 0 by Ii, it's simply our 0. Okay, so Ri become 0. So the I, this Ii, this Ri is nothing but simply 0 ohm. Okay, so we can find this value by using this formula, Ri Vi by Ii. Simple. Okay, so input resistance will be 0, 0 ohm. We can say simply 0 ohm. Okay, now next we have to find the value of Rm. Okay, so now in the circuit, this current is our II, because we have removed this resistance. We have removed this resistance because this 0 0 no current, and II. Okay, and if I am saying this H is a ground, somehow ground potential like this. So if we apply KVL in this loop, okay, if we apply KVL in this loop, like say V naught, okay, remove this one. Okay, in this loop you can say, if we apply KVL in this loop, like this, like this, like this. Okay, so what we can write, Vi is 0, so I am just, but still I am writing it Vi minus II into 10 kilo ohm. Okay, or 10 kilo ohm we can write. Okay, and minus V naught equals to 0. So Vi is already 0, so no need to worry. So V naught equals to minus II into 10 kilo ohm. So this V naught by II is minus 10 kilo ohm, which is nothing but simply our Rm, trans resistance. Okay, trans resistance Rm. So the value of the trans resistance is simply find by using this. What we did, only applied the KVL. Okay, means we have assumed that this one is a ground, or some voltage is there. So Vi plus Vi minus II into 10 kilo ohm minus V naught. So Rn V naught by Vi, keeping I naught 0. Okay, so it should be around minus 10 kilo ohm. Okay, so also the output resistance. So in this case, output resistance R naught will be also 0 ohm. Okay, since we are assuming that op amp is acts as a transresistance amplifier in ideal condition, so op amp has 0 output resistance. So the op amp has 0 output resistance. Okay, now the last one, we have to find the output voltage. Okay, we have to find the output voltage of the transfer resistance amplifier. Okay, so what we have to do for the output resistance, what we can do, very similar thing we have to do for the output resistance. Okay, so what we can do, this one is basically V naught we have to find. So V naught will be easily find by just applying the KVL. Okay, because II is known to us. Okay, RM is also known to us. Okay, II is known to us, RM is also known to us. So V naught value will be RM, V naught value RM into II. Okay, RM is minus 10 kilo ohm. Okay, and II, the main current source is 0.5 milli 10 to the power minus 3 ampere. So okay, one more time, minus 10 into 10 to the power 3, 0.5 into 10 to the power minus 3 ampere and ohm. So this is nothing but simply volt. Okay, so this and this will be cancel out. So V naught equals to minus 10 into 0.5. So it should be simply minus 5 volt. So our V naught will be minus 5 volt. Simple. So V naught will be minus 5 volt. We have used this expression for V naught calculation RM, II. Okay, because II is known to us. RM is now we have calculated minus 10. So V naught will be simply minus 5 volt. So like that we can solve. So this amplifier is used as a trans resistance amplifier. So we have calculated the all parameter, input impedance 0 or input resistance 0, output resistance also 0, the trans resistance value trans resistance RM minus 10 kilo ohm, and the other one the output voltage. The output voltage will be simply minus 5 volt. So this is all about this question, and this one is simple question but little tricky due to this trans resistance amplifier. So op-amp can be used as a voltage amplifier, current amplifier, trans resistance amplifier, and even trans conductance amplifier. So this is all about this question. So thank you for watching this video.